this video, we're going to talk about solving systems of equations. So first, let's just look at solving systems of equations by graphing. So if I'm solving a system of equations, remember that that just means I'm looking for where these lines intersect. And that point of intersection is my solution. So if my two equations, I have 2x plus 3y equals 9, and then I have y equals x minus 2. So y equals x minus 2 is easy for me to graph because it's in slope-intercept form. I need to remember that there's no coefficient, which just means my slope is 1 over 1. My y-intercept is -2. So on my y-axis, I'm going to go to -2 and put a point. And then my slope is +1, so I go up 1, right 1. I'm going to connect these dots and extend my line. Remember that it's super important when we are graphing systems of equations because you need to use a straight edge because where the lines intersect is the solution. So if your line isn't exactly on the correct spots on your coordinate plane, then you could get the wrong solution. So I can fold a sheet of paper in half or use a ruler, whatever it is, to have a precisely straight edge. So I graphed this first equation. In order to graph the second equation, I'm going to solve for y so that it is in slope-intercept form. So my equation is 2x plus 3y equals 9. I want y on a side by itself, so I'm going to solve for y. I'm going to draw a line down my equal sign. I need to add or subtract so that the term with the y in it is on a side by itself. So I'm going to subtract 2x from both sides. 2x minus 2x gives me 0, so those just cancel out. I'm going to bring down my 3y equals -2x plus 9. Lastly, I can divide. I'm going to divide both sides by 3. Remember, each term needs to be divided by 3. And I get y equals -2/3 x plus 3. So that's my new equation that I can look at. It's really the same thing as this one up here. We just rearranged it. So my y-intercept is at 3. My slope is -2/3, so I go down 2, right 3. I'm going to connect my dots and extend my lines in both directions, but I can actually already see what my intersection is. So the solution to this system of equations then is where they cross, which is this coordinate 3, 1. So this coordinate works for both equations. Let's look at solving systems by substitution. The idea is that you substitute one of your variables for the equation. So for example, I have an equation in standard form and an equation in slope-intercept form. So I already have this equation is already solved for y. So what I can do is in place of the y in this equation up here, I can put this side of my other equation because y equals 5x. So in place of y, I can just put 5x because y equals 5x. So what that would look like is I would just solve for x. So we have 2x plus 3y equals 34. I'm substituting in my other equation's value of y, which is 5x, for that y. So this is going to become 2x plus 3, 5x equals 34. And then I'm just going to solve for x. 2x plus, I need to distribute this 3, so 15x equals 34. I'm going to add these together because they are like terms, so I have 17x equals 34. I'm going to divide both sides by 17, and I'm going to get x equals 2. 2 is not my answer because it is still a system of equations, so I still need a coordinate. So in order to have a coordinate, I need to plug this 2 back into one of my original equations and solve for y. That's easier to use this equation, so that's the equation I'm going to use. Y equals 5x. I know that x equals 2, so in place of this x, I'm going to put 2. And I know y is 10. So the solution to this system is 2, 10. And we did this one by substitution. The last way of solving systems of equations is by elimination. Elimination is easy to do when both of your equations are in standard form, but if they're not, I would just recommend another method because it's easy to kind of underthink elimination. So the idea of elimination is if you have negative 2y and 2y, those would add together to cancel out and you would just get rid of one of your variables. So if you can look at your equations and do that easily, that is when elimination is favored. So I'm actually going to manipulate these equations so that that can be done. So this one down here is 3x plus 2y equals 8. So I can realize that if I multiply up here by negative 2, so I would multiply everything in it by negative 2, and I would get negative 8x minus 2y equals negative 28. And I could add that to this equation down here. So we're just going to say that's just all staying the same because I didn't do anything to it. Sorry that it's all kind of squished. I will rewrite it so we can see it a little better. So we multiplied this equation. We didn't change anything. We just multiplied both sides by negative 2. So we kept equality because we manipulated both sides. And I'm essentially just going to add my equations together. So we didn't change the bottom equation. We only changed the top so that we could have something cancel out. So when I add my equations, our negative 2y and 2y cancel out. Negative 8x and 3x gives me negative 5x equals negative 28 plus 8, which is negative 20. I divide both sides by negative 5, and I get 4. That's not my answer. Sorry, I boxed it. We need to now plug in and solve for y because it's still a system, so we still need a coordinate. So if x equals 4, I can choose either of my equations and plug in for our x and solve for y. So if x equals 4, we'll do 3 times 4 plus 2y equals 8. 3 times 4 is 12 plus 2y equals 8. We're going to subtract 12 from both sides. The 12s cancel out. I'll bring down my 2y and I get negative 4. Divide both sides by 2 and I get y equals negative 2. So the solution to this system is 4, negative 2. So those are our 3 methods of solving a systems of equations. I want us to see what this could look like as an EOC problem. My first step when I have a word problem is to read the problem. So I'm going to read this problem. Only chocolate and vanilla ice cream cones are sold at an ice cream store. In one day, the number of chocolate cones sold was 1 more than 4 times the number of vanilla cones sold. A total of 121 cones were sold that day. Let C equal the number of chocolate cones sold. Let V equal the number of vanilla cones sold. Write equations to determine the number of chocolate cones sold that day. Use the equations to determine the number of chocolate cones sold that day. Show your work using words, numbers, and/or diagrams. This is a grid answer, so we would have to type in our answer of the number of chocolate cones sold that day. So that's what needs to be put here. Okay, so let's go back through and identify the information that I know. Only chocolate and vanilla ice cream cones were sold at the ice cream store. That's kind of pointless. I don't really care about that information. In one day, the number of chocolate cones sold was one more than 4 times the number of vanilla cones sold. A total of 121 cones were sold that day. So I'm going to create 2 equations because I know that the number of chocolate cones sold, which we're using the letter C for that, equals 1 more than 4 times the number of vanilla cones sold. So 4 times V, which is our vanilla cones. I also know that 121 cones were sold. So C plus V, my total chocolate cones and vanilla cones, added to be 121. So both of these equations have to be true. So what this is a systems of equations problem. Looking at this, it seems like the easiest way to solve it would be to do substitution. So I have C equals 1 plus 4V, and I also have C plus V equals 121. I'm looking for the number of chocolate cones sold that day. So I know I need to find this intersection. If I'm doing substitution, that means that I need to have one of my variables solved for. So this one has already been solved for. And I'm going to replace that variable, so this C, with that solved equation. So in place of this C, we're going to put 1 plus 4V plus V equals 121. I replaced this number of chocolate cones with what this number of chocolate cones was solved for because they're equivalent, so I can replace. Then I would solve for my number of vanilla cones. So I'm going to do 1 plus 4V plus V equals 121. I'm going to combine my like terms on the left side. I'm going to subtract 1 from both sides. I have 5V equals 120. Divide both sides by 5. And I get my number of vanilla cones as 24. That's not what we want. We want the number of chocolate cones. So I'm going to go back into my original equation, which doesn't matter which one I choose. We could do both. I'm just going to choose this one. C equals 1 plus 4V. I'm going to replace V with 24 to find C. So now I have my number of chocolate cones. My number of chocolate cones is 97. So in my Scantron or gridded response on the EOC, I would go 97 and I would bubble 97.